In this video, we'll be talking about regression. For more on this, you need to subscribe to this channel. We are asked to show how to obtain B0, B1, and B2. Of course, we know that Y is a dependent variable, while X1 and X2 are the independent variables. E is the error term. So we'll now show how to obtain B0, B1, and B2. So you need to subscribe to this channel. Solution. For we to obtain B0, B1, and B2, we need to employ what is called the sum of square error. The sum of square error is given as summation of the error term raised to the power of 2, where I ranging from 1 to n. Of course, from this, if we have y to be equal to b0 plus b1 xi plus b2 x2 plus the error term, we can make the error term the subject formula. It then means that if we make this the subject formula, it means we'll have y minus b0 minus b1 x1 minus b2 x2. The next thing to do is to slot or to substitute the error term into the sum of square error. So if we substitute the error term into the sums of square error, we get the sum of square error to be equal to summation of the error term raised to the power of 2 to be equal to summation of, we now put this here, which is y minus b0 minus b1 x1 minus b2 x2 all squared. So we'll take this as our equation star because we'll recall it back. So the first thing to do, we differentiate with respect to b0. For we to find b0, we differentiate with respect to b0. So the s the b0 is equal to, we are differentiating this. If we differentiate this function, we get 2 summation y minus b0 b1 x1 minus b2 x2 raised to the power of 2 minus 1 from differentiation times, from composite function, we differentiate this b0, and this b0 will give us minus 1. So we'll have minus 1. So to maximize or minimize a function, we equate that function to 0. So here, this can come over here to give us minus 2 summation y minus b0 b1 x1 b2 x2 is equal to 0. It then means, of course, minus 2 is not equal to 0. This will go. So we'll be left with this. We'll be left with summation of y minus b0 b1 x1 b2 x2 equal to 0. If we open this, we sum this. If we open this, we get summation of y minus, if you sum a constant, you get n times that constant. So you have n b0 minus, we have a value here. So we have b1 summation x1 minus b2 summation x2 is equal to 0. And that means that we can keep this to have n b0 plus b1 summation x1 plus b2 summation x2 is equal to, we are pushing this over to this side to give us summation of y. We take this as our equation 1. We now say recall from equation star. From equation star, we can look for the derivative of b1. So our sums of square error divided by b1. Now we are differentiating with respect to b1. So we are differentiating this function. We'll still have 2 summation y minus b naught minus b1 x1 minus b2 x2 raised to the power of 2 minus 1 times, from composite function, we differentiate this. So we have negative x1. So the next thing to do, of course, we have negative 2 summation y b naught b1 x1 b2 x2 multiplied by x1. So of course, this, which is equal to 0. So we still have, we multiply this with this to give us summation x1 y b naught x1 b1, this is x1, x1 multiplied by x1 is x1 squared, b2 x1 x2. Of course, they cannot go equal to 0. So we go over to this side. We go over to this side. We'll allow this to stay first. So of course, negative 2 is not equal to 0, so it goes. The next thing to do is to sum the whole of this. If we sum that, we'll get summation of x1 y1 minus b naught summation of x1 minus b1 summation of x1 squared minus b2 summation of x1 x2 equal to 0. We can push this over to this side to give us b naught summation x1 plus b1 summation x1 squared plus b2 summation x1 x2 is equal to summation x1 y1. This is our equation 2. So we'll now differentiate again in respect to b2. So we say from equation star, which is this, we now say the s, the b2, we are differentiating with respect to b2. It now gives us, of course, we get 2 we get 2 summation y minus b naught minus b1 x1 minus b2 x2 raised to the power of 2 minus 1 from differentiation multiplied by from composite function the differential of this. If we differentiate with respect to b2, we get negative x2. So we have it as to minimize or maximize a function, we equate that function to 0. Of course, we now have, and delete this, delete this. No. So we have negative 2 summation. We multiply at once. We have x2y minus b naught x2 b1 x1 x2 b2 x2 squared. 2 minus 1 is 1 equal to 0. So, of course, negative 2 is not equal to 0. This and this will go. So we'll have, if we sum the whole of this, we get summation of let's open the brackets, x2y minus b naught summation x2 minus b1 summation x1 x2 minus b2 summation x2 to be equal to 0. So we can move this over to this side. For we to move it over to this side, we also come again to this place. Okay, let's ignore this. If we move it over to that side, we get b naught summation x2 plus b1 summation x1 x2 plus b2 summation x2 is equal to, this will move over to this side to give us summation of x2y. We put this as our equation 3. So we have here as our equation 1, we have here as our equation 2, and we have here as our equation 3. All we need to do is to spell them out before we can find the solution to b naught, b1, and b2. So we spell them out. So combining equation 1, 2, and 3, combining equation 1, 2, and 3, we get equation 1 is n b naught plus b1 summation x1 plus b2 summation x2 is equal to summation y. This is our equation 1. Equation 2. This is our equation 2. So we'll bring it here. B naught summation x1 plus b1 summation s squared 1 plus b2 summation x1 x2 is equal to summation x1 y. This is our equation 2. And the third equation, which is this, we'll bring it forward. We have b naught summation x2 plus b1 summation x1 x2 plus b2 summation x2 is equal to summation x2 y, equation 3. So the next thing to do, as we can see, we cannot readily bring them out easily. The next thing to do is to put them in matrix form. Of course, if we want to get the solution of this, is to put the whole of this in matrix form. And if we understand that concept, it will be very easy for we to compute that. Of course, if we want to write our x, the values for x, to put in matrix form, to put in matrix form, because that will be the easiest way to compute this. X, of course, will give us 1, 1, 1. X1, 1. X2, 1. X1, 2. X2, 2. Of course, this will give us x1n and x2n. That is what we get for our x values. How about our y values? Our y values will give us something like this: y1, y2 to yn. How about our b values and our error term? The same thing is applicable. Our b values, we come over to this side. To write our b values and that of the error term. That is how we can easily obtain them. You need to subscribe to this channel, and an example will convince you the more. So our b values, the same thing, we get just like this: b1, b2 to bn. Also our error term, we get e1, e2 to en. So it means that for the normal form, for the normal equation, if we want to solve it in matrix form, for the normal equation, we'll have something like x transpose x multiplied by b to be equal to X transpose Y. And to obtain our B, that is solution for B, we'll have B to be equal to X transpose X raised to the power of minus 1 multiplied by X transpose Y. So with this, we can compute the regression model or the regression equation given for B0, B1, and B2. So for more on regression, you need to subscribe to this channel.